So yeah, hello everyone, I'm Kasey and I'm just going to talk a bit about compression garment development if you haven't heard enough already. So I am a PhD researcher here at the University of Manchester and I've actually only got 2 months left, so I'm nearly finished, which is pretty terrifying. So the focus was developing sizing methodologies around women's sports compression leggings. And I was able to work with a couple of people from industry, so someone from Hohenstein Institute in Germany, and also Karen McDonald from the IEEE Standards Association, just to be able to effectively complete some of the research projects that I've worked on. And I was able to work on a couple of other projects, one of which was looking into bespoke compression calf sleeves for a particular demographic as well. And again, I won't go into much detail about what compression garments are. Zishan already spoke about that. So I'm just going to talk about a couple of issues that I see within research. One of which is such a big focus on the big question, do they work? And the kind of controversy around that. Kind of problem is, when I was looking, was there's no reporting of fit observations and pressure measurement prior to actually testing. Fit and pressure delivery is essential for the garments to actually work. So if you don't know how much pressure the garments are applying during the testing, you can't say whether they work or not. So some of the conclusions that have been drawn from researchers could be essentially invalid. There's no consistency with testing protocols either, which also makes it a lot harder to get consistency with results. And there is a lack of interdisciplinarity between studies. And when compression garments are so complex, you really need to kind of work with people from different disciplines to really be able to get a good developed well-fitting garment that actually is able to function. So I'm just going to briefly describe some of the studies that I did for my PhD research without going into too much detail, I'm very conscious of time. So this is one of the first things I did. So there's little to no research into kind of stretch pattern cutting and sizing of compression garments. Which is even more frustrating when industry practice is also kept very secretive because of the perceived commercial value of this information. So in order to try and get a bit more of an understanding about the processes, I interviewed a couple of industry experts in the field of sportswear and compression wear and their sizing as well. So I found out that the sizing and grading is done really based on experience rather than actually any theory, which is a big problem. And also those that are employed in these roles, especially junior pattern cutters, for example, they can't be expected to understand like the complexities of compression garments. And they also are very busy and have a lot of work to do, and this garment is just another garment that they need to get through. So this might be different in specialist compression garment companies, but again, there's no theory that underpins the sizing process in compression garments, so it's likely to be very similar. Another thing is also lots of companies still don't have access to scan data of their populations because it's actually very expensive to buy scan data from companies. So a lot of them are still using, again, experience and working from what other companies do, and also some companies that may buy the scan data might not be able to actually use the data effectively in the product development process. So it was also important for me to test the commercially available garments, kind of how they were assembled, what materials they were used for, what materials were used to actually make them, and kind of what size designations and offerings that each company had. So I also wanted to see whether an athletic female population was also catered for by these companies, as an athletic body is the type of body that they should be targeting. So what I found was that overall pressure delivery was a lot lower than I'd expect, especially one of the brands produced very, very low pressures to the point where I don't think any benefits would have been felt by anyone. There was also a lack of consistency even across the sizes of each brand, let alone between each brand. Seam placement also differs dramatically between the three garments, really showing kind of a lack of understanding of how seams can affect pressure distribution. The mechanics of compression garments are really complicated, so many factors can affect pressure delivery. Whilst you might think that, I don't know, a garment that had the highest tensile strength would produce the most pressure, it wasn't necessarily the case when I was doing my testing. And this could be due to actually how the garment was being constructed. And then in terms of the size designations, there was again no consistency between brands, which led to actually only 3% of the participants that were in the study were actually able to buy the same size in all three brands. Then when comparing scan data of athletic females to the brand's size charts, as well as with the Alvanon UK standard dress forms, it was clear that some of the brands didn't cater for an athletic female figure. As little as 11% of the study population were able to confidently choose a size from one retailer, which is pretty low. The size offering was very similar to, and even for one brand exactly the same as the Alvanon standard dress forms, which are an hourglass body shape, which is rarely seen in reality and kind of relies on proportional grading. So assuming that if someone has a larger waist, they are proportionally bigger everywhere else on the body, which again is probably not accurate in reality. So the method of grading is definitely outdated and needs reviewing. And another big problem was that one brand was using height and weight in their size charts as their key dimensions, which again really shows lack of understanding about body dimensions. In various studies, it has been shown that height has absolutely no correlation with weight and other circumference measurements. And in terms of lower body compression garments, it's really necessary for probably at least one limb circumference to be used in the size charts, as it's the circumferences that will actually affect the pressure delivery the most. So the next thing I looked at was actually trying to understand the body's movement and how this can affect garment development. So when the body moves, the dimensions change, so essentially the interface pressures will constantly fluctuate. So whilst maintaining the exactly same pressure is probably impossible during movement, it's really important to maintain enough pressure for the garment to actually be able to function and deliver pressure to the body, but also keeping it low enough for there not to be any detrimental effects. This is really difficult to determine because currently there are no standards for pressure levels for sports compression garments, so it's very difficult to say how much pressure would be enough for one person, but also too high for it to be badly affecting another person's body. So 3D and 4D body scanning technology was used to capture functional static postures and dynamic movements. However, scan software isn't really ready to automatically extract measurements from these kinds of bodies yet, so alternative softwares have to be used for this. So the study Rhino and Grasshopper were used to try and extract measurements from this, but you really do need someone who is really proficient in using the software to be able to do this, and it's really time consuming. So the aim was to kind of use pressure measurement ranges during movement to predict pressure fluctuations, which then could be used potentially to influence pattern developments and fabric development. Again, this is difficult as pressure prediction methods that have been used by others in various research and as well by myself don't really work and have definite differences between the prediction and the actual measurement when you're measuring on a person. So the 4D scanning also requires further advances in order to accurately capture the scans, and then obviously measurement extraction is impacted by this as well. I was unable to actually use some of the scans that I have due to the scans just not being clean enough to be able to actually accurately get any measurement data. So I'm just really going to look at a few research opportunities for the future, things that I'm interested in myself, and things that I think are really necessary. So standards for comfortable and effective pressure levels need to really be established for sports compression garments, and standardisation between testing protocols. Performance-based testing can then be done with fit and pressure evaluation prior to the testing, and testing with various pressure levels as well. Working on accurate pressure prediction models and advances with virtual fit as well to enable accurate pressure mapping. Accuracy of 4D scanning, again, like I just mentioned, really needs some improvements to get that auto extraction from the data. That can be applicable to pattern drafting, and a lot more interdisciplinary research is needed involving like academics and people from industry in different areas. And lastly, a few research areas that I'm particularly interested in looking at is pressure applications on different types of tissue. So like muscle versus adipose tissue, kind of determining how pressure may affect different bodies, working with athletes and potentially industry to develop parametric patterns for compression garments that can be adapted to an individual athlete's body measurements. And also looking at sport-specific bodies and the differences in body types and measurements for different sporting disciplines. Again, hopefully working with actual athletes, although this has proven very difficult within my own research. So thank you, and yeah, happy to answer any questions.
Okay. So yeah, as per normal, are there any questions from the floor?
Thank you, Kasey. Congratulations on your presentation and almost finishing. I just wanted, you mentioned at the beginning that you were working with somebody from international standards. I wondered if that is something that you've got in like a draft form or recommendations of what those testing protocols might look like? Or I know you mentioned it's future work, just wondered how far.
Yeah, so in terms of the Carol from IEEE, it was more, her involvement was more with the measurement extraction. She works on identifying like landmarking and measurement extraction. So it was that area that I was kind of working her with rather than anything else. Yeah.
I'll go with George first at the back.
Thanks. Kasey, thanks for that. That's a really interesting area of research. Can you make an estimate of how many sizes you would need to accommodate, let's say, 90% of the population?
As many as possible. It's really hard to say how many. It really depends on kind of the data that you had, like from a really large population of scans, and also depending on how specific you went in the population. So I feel like it's more important to tailor the garments to as small a population as possible, rather than trying to cater for the masses and giving loads of sizes. Because what I found, even the companies that offered quite a lot of sizes, loads of women actually just fell in between the sizes quite a lot of the times. So I feel like it's hard to say how many, but I feel like focusing your target population is probably better than trying to just do loads of sizes and hope that that works.
Time for one more question, Rebecca.
When you were talking about everything that's wrong with the commercial garments, basically all the different brands are different.
Yeah.
I mean, I think it's probably fair to say that that is across all sportswear,
Yes.
isn't it? It's like you find your sportswear brand that you like, you
Yes.
stick with it. I guess the thing I'm kind of thinking of is this important for compression wear because the claims don't work if it doesn't fit? Because I guess I'm thinking that people can pick the brand that works for them and then they stick with it, which is what happens. But does that mean that in compression wear they're not necessarily getting the benefits that the box says?
Possibly, and I think that's quite a lot of the time why companies don't say how much pressure like their garment is supposed to apply, because I think quite a lot of the time it might be the case that they're not applying very much pressure. So it's, I think hard for companies to be like, oh yeah, our garments want to provide this much pressure if they don't work. Like that's quite a big claim to make. One of the garments I did test were from the 2X2 garments.
Yes.
And they actually did claim an amount of compression which I think was somewhere between 20 and 25 millimetres of mercury at the ankle. And when testing, they were actually kind of the closest to that. The others who don't try and say, oh yeah, like this much pressure, are actually the companies that didn't provide really enough pressure for anything to happen. So
is it almost like we're trying to retail a product that's a little bit too technical for just the masses?
I probably think so. And that's why I think it's really important to focus on like an athletic population and understanding their body and trying to cater for them, because I think that they're the people who are buying these products. They're expensive, and these people know that they're going to actually get some benefit from them, and they're going to buy from the companies that actually say, we know that we're going to provide you with this much pressure. And I do think it's better to cater for these people rather than to generalise for people, because I don't think it works.
We'll draw to a close there. Conscious that I might have let things run over time, which is unlikely. It's an interesting discussion. You can pick up. Thanks again.